I am Venkatesh, second CS in SRIT. Today my topic traveling salesperson problem using dynamic programming. Traveling salesperson using dynamic programming. Introduction to TSP. The traveling salesperson problem is a classic optimization problem in computer science and operation research. Traveling salesperson in TSP. It involves finding the shortest possible route that visits to set of cities and returns to the origin city. TSP in NP odd meaning to know. Non-polynomial time algorithm can solve all instances of it efficiently. Very famous problem, many practical application, very easy to describe, very difficult to solve. We shall consider the dynamic programming DP approach. Importance of TSP. In TSP is the practical application in logistics, web planning and manufacturing. It helps us optimize the routes for delivery services, reducing traveling cost and time. Understanding TSP can lead to better algorithm and solution in related optimization problem. Dynamic programming overview. Dynamic programming is a method for solving complex problems by breaking them down into simpler subproblems. It is used to concept of overlapping subproblems and optimal substructure to find solution efficiently by storing previous computed result. Dynamic programming avoids redundant calculations. TSP information. The TSP can formulate as a graph where cities are nodes to distance to edges. The objective is to minimize the total travel distance while visiting each city exactly once. A common formulations involves representing the problem as a cost matrix. Dynamic programming approach. The dynamic programming approach is a TSP. TSP is often implemented using bitmask to represent visited cities. The state can be defined as the minimum cost of visiting a set of cities ending at a specific city. There is recursive related helps build a solution by considering all previous states efficiently. Bitmask representation. A bitmask is a binary representation that indicates whether the city has been visited. For example, if there are four cities, the bitmask 0110 indicates the cities 2 and 3 have been visited. This representation allows efficient tracking of visited cities in dynamic programming solution. Recurrence relation. The recurrence relation for the TSP is defined as dp mask of open bracket I bracket min dp mask stimulus cost. Here mask represents the set of visit cities and I is the current city. This relation computes the minimum cost by considering all possible previous cities from which we can arrive at I. Complex of dynamic programming TSP. The time complexity of the dynamic programming solution, where n is the number of cities. This complexity arises from the need to calculate and cost a very combination of visited cities. Despite being exponential, this approach is significantly more efficiently than brute force method to moderate and sized instance. Limitations of dynamic programming TSP. The dynamic programming approach becomes impactual, impact, practical for very large instance of TSP due to its exponential complexity. Memory consumption can also be concurrent as storing result. All subsets of cities require substantial space. Alternative sticks and approximation algorithm are employed for larger data sets. Conclusion and future direction. Dynamic programming provides a powerful framework for solving TSP, yielding optimal solution for smaller data sets. Ongoing research focus on improving algorithms and developing hybrid method to tackle larger instances. Understanding TSP through dynamic program enhances our ability to solve complex optimization across various fields. Reference Common TH Larson CE Reversed RL and Science C. Introduction to Algorithm Bit Decrease held in M and Crap RL 1962 Dynamic Programming Processing Problems Journal of the Society Industrial and Applied Mathematics IEL 1985 Traveling Salesman Problem Guided or Combinatorial Optimization will be. Thank you this giving opportunity.